Hello and welcome back to the Math Together Canada YouTube channel. Today I'll be going over the 2026 Pascal Contest. So yeah, let's get started. Okay, so for part A, question 1, the value of whatever that is, you can just combine them by 2's, like that. So then there are 4 of these groups and all of them evaluate to 1. So the answer is 4. Okay. Question 2, the value of root 37 is closest to. And this is obviously 6, right? Because 6 squared is equal to 36. So it's between 6 and 7 squared is root 49. 7 is root 49. And 36 is a lot closer to 37 than 49 is. Okay. Next question. So 2 plus 2 plus 2 plus 2 is equal to 2 to the x. What is x? So the left-hand side is equal to 4 2's added together, which is 8. And 8 is equal to 2 to the power of 3. So x is 3. Okay. Question 4. If those numbers were arranged from least to greatest, what would the middle number be? And if we look, okay, so the middle number is obviously the smallest, right? Because it's 2.25. And then the next smallest would be 2.3, and then it would be 2.45, and then this, which is 2.75. And then finally this, which is 2.9. So if we arrange these from least to greatest, then the middle number is 2.45. Okay. Question 5. In the diagram, 9 edges of a cube are visible. How many are not visible? I guess you could just realize that in a cube there are 12 edges, and since 9 of them are visible, 3 of them are not visible. So the answer is 3. Okay. Question 6, which path is the shortest? So essentially what you can see is that 1, 2, 4, and 5 are, 1, 2, 3, and 5 are all the same length. You could either just count that out, or you could just see that, like, for figure 2, for example, you could replace the 2 that curve in with those 2. And then for figure 3, you could replace the first curve with this. And then you could replace that curve with this. And so that would be 8 as well. And for 5, you could again just pull out all of the curves. So then that would become that, and then that, and then that. And that's still 8. So 1, 2, 3, and 5 are all 8. But for 4, you see that if you pull it out, then this is equal to 8. But since you have a diagonal over here, you see that that's less than what it would have been if you had all straight edges. And so the answer is D, figure 4. Okay. Question 7, a train consists of one engine and n cars. The length of the engine is 20, and each car has length 15, and the combined length is 140. So first, you can subtract 20 from 140 to get 120, which is the length of all of the cars combined. And then you do 120 divided by 15, which is 8, to see that there are 8 cars. Okay. Question 8, which of the following integers has the same remainder when it is divided by 3 and 4? You could either go through each of them one by one and see that 13 is equal to 1, the remainder, when it is divided by 3 and 4. Or you could just see that 3 times 4 is equal to 12, and then 12 plus 1 is equal to 13. So then 13 is congruent to 1 when it is divided by 3 and 4. Okay. Question 9. So in the diagram, PQT is equilateral, and QST and QRS are right-angled triangles, and QR is equal to RS, and then you are given that STP is equal to 120 degrees. So essentially, you see that PTQ is an equilateral triangle because all three of its side lengths are equal. So that means that all three angles are also equal. They're all equal to 60. So you have 60 and you have 60. And then you know that PTS is equal to 120, which means that STQ is equal to 60. So then SQT is equal to 30, which is 90 minus 60. So then you also see that SRQ is a 45, 45, 90 triangle because SR is equal to RQ. So SQR is equal to 45. And so if you add all of these together, then you get 135. Okay. And for question 10, how many of these 4x4 squares have exactly 25% of their area shaded? So if we look at them one by one, obviously the first one has a quarter shaded because it's split into 4 quarters and there is one that's shaded. For the second one, you could sort of move this over to this. And essentially you see that that's still 1/4 shaded, right? So that's also good. For the next one, you see that, I'll change it to red. So this is 1/2 of the area of the square, but you see that the shaded region is much more than 1/2 of the red triangle. So this is not 1/4. For the next one, you see that it's split into 16 little squares, and then 5 of the 16 are shaded. And 5 over 16 is not equal to 1/4, so this is also not. Okay. For the next one, you could move this over to this, and then you could move this over here, and then you'd see that you have basically all of this shaded and all of this shaded, and that is a lot greater than 1/4 of the area. That's 1/2 of the area. So this is also not true. And finally, for the last one, you can draw a line over here and then just look at this half. And you see that off that half, another half of that is shaded. So 1/4 of that entire square is shaded. So in total, we have 3 of the 4x4 squares with 25% of their area shaded. Okay, moving on to part B. So, in the diagram, the number placed in each rectangle must equal the sum of the numbers in the 2 rectangles directly below it. And then we want to find y. So first of all, we see that over here you have 9 and 2. So then you could write 11 over here. And then for the next one, you have 11 and 18. So then you can write 7. And then for 2 plus something is equal to 7. So the other blank is 5. And then 5 plus 1 is equal to the last blank, which is 6. And we know that x is equal to 4. So then y is equal to 6 plus 4, which is 10. Okay. Question 12. The point P is reflected in the x-axis and then moved 3 units left. So if we first reflect it in the x-axis, then you would get from 2, 3 to 2, -3. And then if you move it 3 left, then you get that point, which is -1, -3. Okay. Question 13. Max is given B books, and then in March he read 1/3 of the books, in April he read 5 more, and then he had 7 left. So that means that after April, before April, after March, he had 5 plus 7, which was 12 books left to read, and that was equal to 2/3 of the original amount that he had. So if you multiply 12 by 3 over 2, then you get 18. For 14, WXYZ has length 15 and VZ is equal to 17. What is the area of VXYZ? So you see that VZ is 17 and WZ is 15, which means that by Pythagorean, WV is equal to 8. And since Wx is 15, that means that Vx is 7. And you see that xy is 15 and yz is 15. So if you take the area, that would be 7 plus 15, which is 22, divided by 2, which is 11, times 15, which is 165. Okay, question 15. So Peter's car uses 10.2 liters of fuel per 100 kilometers, and Mike's uses 6.6 liters per 100 kilometers, and fuel costs 140 per liter, and they both drive 200. So essentially what we see is that Peter's car uses 10.2 minus 6.6, which is 3.6 liters more per 100 kilometers, which means that it's 7.2 liters more per 200 kilometers. And then it costs $1.4 per liter, and you have 7.2 liters extra, which means that you multiply those together to get $10.08 more that Peter spends. Okay. 16. P, Q, R, S are 4 points on the line segment in that order. PR is 8 and QS is 15. What is the smallest possible integer length of PS? So we know that Q and R are distinct points, which means that QR, the length of QR has to be greater than 0. And the length of PQ also has to be greater than 0. So that means that if we want the smallest possible length of PS, that means that we want the most overlap between PR and QS. So we want QR to be as large as possible. And because PR is equal to 8 and PQ is greater than 0, that means that QR can be at most 7. And then PQ is equal to PR minus 7, which is 1. And then QS is equal to 15 minus 7, which is 8. So then the least possible integer length would be 1 plus 7 plus 8, which is 16. And you see that that is the least because that's the least out of the 5 answer choices. Okay. 17, we have 4 out of the 5 puzzle pieces which can fit together to create a square, and which piece is not used. So I guess we just see which ones fit together. So for example, for 1, you could either put 4 to the right of it or 3 to the right of it. And we can try 3 first, I guess. So let's draw it in red. We would have the triangle go over here, and then we'd have and then we have a little thing sticking out, or not sticking out, sorry, curving in. And so that would be 3. And then after that, we need to have an oval shape like that, which is either 2 or 5. And so if we first try 2, then we see that there's that, and then there's another oval shape, right? So then we would need a shape with an oval curving out, and then a trapezoid curving in. And we see that 5 has that. So if you flip 5, then you are able to fill in the square. Let's just fill it out. And so that would be 1, 3, 2, and 5 in that order. And 4 does not get used. So the answer is piece 4. Okay. Question 18. When the integers from 17 to 352 are added, the sum is that. And then we want to find the sum when 20 to 355 are added. I guess you could just count or add that manually. You could do the Gauss thing where you add the first and last, and then you count the amount of numbers that are in there, and then you multiply those and divide it by 2. Or you could count that from 17 to 352, there are 336 numbers, and then you're adding 3 to each of the 336, so then you multiply that by 3 to get 1008, and then you add 1008 to 61992 to get 63,000 as your final sum. Okay. Question 19, how many squares of all sizes are in the diagram? They already give you that there are 34 1x1 squares. And then to count 2x2 squares, you first consider this little rectangle in the middle. And in that rectangle, there are 3 times 1, 2, 3, 4, 5, 3 times 6, which is 18 square 2x2 squares, because you're like, so for each row, I guess, like 2 rows, there are 3 squares, and then there are that until that, which is 6 pairs of rows that are adjacent to each other. So then that's 34 plus 18 in the middle. And then if you consider those with like an extra square to the side, there's 1, 2, 3, and 4. So then you add 4. And so there's 22 2x2 squares. And then for 3x3 squares, you can do the same. You can split it into like a rectangle in the middle, and then the rectangle is on this side. So in the middle there would be switch it to blue. So there would be that and that. So 2 3x3 squares per 3 adjacent rows, and then there would be that until that. Until that, which is like 1 2 3 4 5. So that would be 5 what are they called, 5 adjacent like 3 rows. So then if you multiply 5 by 2, that would be 10. And then for the ones that are not included in that rectangle, there are this and this. So you add 2 to that. And then there's 4x4 rectangles. So if we erase this, and then now we don't have to consider the ones on this side anymore because there's only 3 over here. So then if you just count the number of 4x4s, there's 1, 2, 3, and 4. So then you add 4 to that. And then if you add all of that together, you get 56 plus 16, which is 72. And of course, again, you can see that that is the correct answer because 72 is the largest number over there. So, yeah. Okay, question 20. So a bag contains 6 coins, which are 2 quarters, 2 dimes, and 2 nickels. And then you want the probability that the combined value is 30 cents or more. So essentially, in the denominator, there's a total of 6 choose 2, which is 15 ways to choose the 2 coins. And then to make it 30 or more, you would either have 2 quarters, a quarter and a dime, or a quarter and a nickel. So for 2 quarters, there's one way to do that. For 2 quarters and 2 dimes, for 1 quarter and 1 dime, out of those, you would have 4 ways to choose those because there's 2 quarters that you choose from and 2 dimes that you choose from. And it's the same thing for quarters and nickels. So 1 plus 4 is 9, and then 9 over 15 is 3 over 5. Okay. So for question 21, a lock has these characteristics, and how many possible lock combinations are there? So you see that if the first digit is 1, then the next digit could be 2 all the way to 8, right? And then you would have a possible third digit, which is 3 all the way to 9. And so there are 7 possible combinations with first digit 1. And then for 2, you have 3 all the way to 7, because the second and first can't be equal, and 2 plus 7 is equal to 9. So then there's 5 combinations. And then for 3, you would have 4 all the way to 6, so 4, 5, 6, and that would be 3. And finally for 4, you would just have 5, which is 1. And if you add these together, 7 plus 5 plus 3 plus 1 is equal to 16 lock combinations. Okay. Question 22. Consider the 5 distinct integers. Those, their mean, average, and median are equal. What is the sum of all possible values of x? So essentially, you can order the ones that we have so far. They're 8, 11, 16, and 17. And then, so you see that 8 and 17 cannot be the medians because there's 3 numbers to one side of them. So then the possible medians are 11, 16, and x. And notice that the sum of the numbers that we have already is 33 plus 19, which is 52. And that's going to be useful for calculating the mean later. So first we do casework. So if the median and mean are equal to 11, then that means that the sum of the 5 distinct integers is equal to 55, which is 11 times 5. So then x would be 3. And you see that that's possible because 3, 8, 11, 16, 17, 11 is the median. Okay. And then case 2 would be if both the mean and the median are 16. So then the sum of the numbers would be 80. So then x would be 28. And that's also possible because 8, 11, 16, 17, 28, the median is 16. And finally, if the median is x, then the sum would be 5x. So then 5x minus x is equal to 52. So x is equal to 13. And once again, that's also possible because 8, 11, 13, 16, 17, the median is 13. So then we add these 3 integers together, and then we get the sum is 44. Okay. Question 23. I guess you could basically they already draw these lines in for you, so I'm just gonna make them a little bit more obvious. Essentially you're calculating the area of the shaded region, and you have that the side length is 10. So what I do is I first take the triangle that we already have drawn here with one side length 10 and the 2 red edges, and then you see that the area of that region is equal to well, I guess you could first see that if you draw this line over here, then you would have 5 and 5. And then you would also have 5 over here, so then this length would be 5 root 2. So then the area of that triangle would be 5 root 2 times 5 root 2 over 2, because it's a right triangle, and that would be 25. So then you have 25, and then you subtract the area of, or you subtract that from the area of the semicircle, and then that would give you this and this. Right, so the area of that semicircle is equal to 5 squared pi over 2, which is 25 pi over 2. And that's equal to essentially one of the 4 petals, because you can move this highlighted area over to here, and then that would create 1. So then if you want to calculate the area of all 4, then you just multiply this number by 4, and then you would get 50 pi minus 100, and the integer closest in value to that would be 57. Okay, question 24, the string of digits that is formed by that, and then you want to calculate the sum of the first 2026 digits. So you could pair, or I guess not pair, but you could group the digits like this. So you have 1, 2, 3, 4, 5, and then you have 1, 2, 3, 4, 5, 5, and then you have 1, 2, 3, 4, 5, 5, 5. And you just continue that, and you start a new group at 1. So for the groups, there are 5 plus 6 plus 7 all the way digits, And you want the sum to be 2026, which is given when you get to 63 digits in a group and then 64 digits in a group. And notice that for the last 64, you're only taking the first 20 digits. And I guess you calculate that by just seeing that like 5 plus 6 all the way to 63 plus 20 is equal to 2026. And so to calculate the sum of the 2026 digits within this, you see that there's 64 minus 5 plus 1, which is 60 groups that you're calculating, and you have 1, 2, 3, 4 in all 60 groups. So then the sum of the 1, 2, 3, 4s would be 600. And since you have 60 groups and 4, 1, 2, 3, 4s per group, you have 240 that are not 5. So then there's 2026 minus 240, which is 1786 5s. So then you add 1786 times 5 to that. And then you get that S is equal to 9530. And then you want the sum of the digits of S. So then that's 9 plus 5 plus 3 plus 0, which is 17. Okay, and lastly, question 25. So triangle ABC is equilateral with side length 6, and then you cut out 3 smaller equilateral triangles, and you're left with a hexagon that can be tiled or divided into n identical equilateral triangles. So first, we can write out the formula for the area of an equilateral triangle, which is root 3 over 4s squared, where s is the side length. So we see that after we cut out the 3 triangles, we would have the remaining area is 6 squared minus a squared minus b squared minus c squared. And then we can write out all possible triples ABC that satisfy the constraints in the problem. So then you have 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, 1, 2, 2, 1, 2, 3, 2, 2, 2, and 2, 2, 3. And then you see that for each of these, 36 minus a squared minus b squared minus c squared is 33, 30, 25, 18, 27, 22, 24, and 19. And obviously each of these can be tiled into triangles with side length 1. So you have 33 plus 30 plus 25 plus 18 plus 27 plus 22 plus 24 plus 19. Right. Okay. And then next we have these when the equilateral triangle has side length 2. And we see that over here the only number divisible by 4 is equal to 24. And when you remove 2 or if you remove 3 equilateral triangles with side length 2, so ABC are equal to 2, you see that you're left with a hexagon that can be tiled into triangles with side length 2, because I guess I can draw it out. You have that, and then you're removing that, and that. But you're still left with that. That's not accurate. Okay, whatever. Let's redraw that. Okay, I think that's a bit more accurate. So then you're left with that, and then you can tile that into that. So for the 2s for 24, it's still possible, so you can add a 6 to this. And then for 3s, you have 18 and 27 are multiples of 3 squared, but neither of those are able to be split into equilateral triangles with side length 3. And then for 4, there's none of them that are multiples of 16. And then for 5, 25 is a multiple of 5 squared. But you cannot split the hexagon into one equilateral triangle of side length 5. So this is our final sum, and it is equal to 204. So then we want the rightmost 2 digits, which is 04. And that was the 2026 Pascal contest. Stay tuned for upcoming Waterloo contest videos, and see you in the next video.